Well, hello there folks, I hope you're doing well. In this video we're going to be talking about chapter 8.3, Calculating Length, Sine Ratio. Put a circle around the label. We'll do the try these first. Put a circle around the label on the opposite side of angle A. Well, this here is angle A, so the opposite side of angle A is right here. The next one says put a triangle around the label on the hypotenuse. The hypotenuse is our longest side. It's also the side that's opposite angle C, the right angle. Either way, 3 meters is going to be our longest side. It then says put a box around the label on the adjacent side of angle A. Adjacent means next to. We have two that are actually next to the box, next to angle A. However, one of these is the hypotenuse. So the side that is not the hypotenuse, that is next to A, is called the adjacent side. So that's what I will put a box around. Now for an example, or a beginning thing. The city of Airdrie, Alberta is building a skateboard ramp with an elevation angle of 40 degrees for a new skate park. How long are the support beams represented in the diagram? Which side, or what sides are opposite angle A? Name 2. Angle A is right here, so the sides that are opposite are going to be each of those 4 sides there. So ED would be one of them, and GF would be another one of them. But IH and CB would also be opposite angle A. Now it says measure the lengths as accurately as you can, recording your results in the chart. And you're going to be using this chart in 8.4 and 8.5, so hey, maybe do a good job of it. So I measured as carefully as I could, and I got the results using my ruler. AE I measured as 20 millimeters, so that's from here to here. So I measured that to be 20 millimeters. A to G, so all the way over here, is twice that, 40 millimeters. There's also a blank spot for a third one, so I decided to just go to the next one. A to I, so side AI, is once again another 20 millimeters or 60 millimeters. The next is the opposite side. So opposite angle A, we have ED, this side right there, and I measured that to be 12.5 millimeters. GF is twice that, 25 millimeters. And I decided to go with IH and measured that one to be 37.5 millimeters. Finally, the adjacent sides. We have AD, the bottom first little triangle there. I measured that to be 15 millimeters. A to F, I measured to be twice that, once again, 30 millimeters. And I decided to go for the next one, AH, which is 45 millimeters. If you notice that each side goes up by a constant amount, so the hypotenuse went up by 20s, opposite side went up by 12.5, and the adjacent side went up by 15 each time. Number 3 says, what is the ratio for the opposite side of 40 degrees divided by the hypotenuse? So we have a few ratios set up here. ED divided by AE, so ED is 12.5 millimeters. AE is 20. And when I put that in my calculator, I get the answer of 0.625. GF is 25 millimeters, and AG is 40 millimeters. But when I put it in my calculator, I get once again 0.625. I notice they are the same. There's a reason for that. There's a reason, which we will get into in a moment. For the next part, it says you can use a scientific calculator to determine the sine of an acute angle in a right triangle. What is the sine of 40 degrees? So I put in my calculator sine 40 degrees, and I should get the answer to 3 decimal places of 0.643. Now, if you did that, put that in your calculator, and you got the answer instead of 0.745, you're in the wrong mode. what you need to do is hit the mode button. It's right next to the second button near the kind of top left of the keypad of your TI-84. When you click the mode button, you'll see, I think about 3 down, there will be a list where it says radian and degree. And so go down to that one, and a radian will be shaded in on your calculator if you got the wrong number. So you want to go down to that one and push the right button to go on top of degree, and then hit enter. Once degree is highlighted, you can now do second mode, which is the quit button, which will bring you back to the normal calculator part. And now when you put sine 40, you should get the right answer of 0.643. What do you notice about 0.643? Well, it might not be totally obvious, but 0.643 is close to 0.625. And that's going to become important in a moment here. For the next part, part 5, we have draw 2 different right triangles with a 25-degree angle. Measure the sides, compare the opposite side of 25 degrees over the hypotenuse in the 2 triangles. What do you notice? Well, basically do the same thing. I'm not going to do that, but if you were to do that, you would notice that once again, the ratios are the same. So what conclusion can you make based on your results? Excuse me. Well, it means that triangles with the same sides have the same ratios. So I'll put that first. Triangles wow, what just happened there? Triangles with the same angle. Sorry. Triangles with the same angles these are called like triangles, by the way, have the same ratio. Have the same, I'll say, side ratio. Also, the sine of the angle is equal to the opposite side of the angle divided by the hypotenuse. There we go. It says save your diagrams for later in this chapter. So if you make them, save them. Let's do a couple of examples now using this information. Lois is cleaning the rain gutters around a roof. At what height does her ladder touch the building? Round to 1 decimal place. Well, we have some information. So this is the 74 degrees. We have the opposite side is our unknown, and the hypotenuse is 10 feet. So sine 74 degrees is equal to an unknown height divided by 10 feet. I want to get that unknown on its own, so what I need to do is multiply both sides by 10 feet, and that's what we do. So we have sine 74 times 10 feet is equal to unknown divided by 10 times 10. Well, if I have divided by 10 times 10, those guys just cancel each other out, and I'm left with sine of 74 degrees times 10 feet is equal to 9.6 feet when rounding to the 1 decimal place. Now, if you got the answer instead 0, that means you didn't close your bracket. You need to close a bracket. So if you have, when you push sine 74, if there's a bracket there, close that bracket and then multiply by 10. Or you could always just do the opposite. You go 10 times sine 74, and that'll always work too. Either way, you should get the answer of 9.6 feet. For example number 2, we have a communications tower that is 20 meters tall. For extra support, cables must be attached. How much cable is needed to the nearest meter? Well, we have once again our angle here, and the opposite side is our 20 meter side. And this time we're trying to find out the hypotenuse. The hypotenuse is often called c because of the Pythagorean theorem, where it's represented by c. So we'll put in the information we know. 20 meters. I want to get c on its own, but it's on the bottom. I need to get it on the top. The first thing to get it on the top is to multiply both sides by c. So when I multiply both sides by c, it cancels out on the right side, and I'm left with c times sine 60 is equal to 20 meters. I want c on its own still, so I need to divide both sides now by sine 60. So I get c is equal to 20 meters divided by sine 60, which when I put in my calculator will give me the answer of 23 meters. So the length of the hypotenuse of each triangle is 23 meters, but there are 2 sides, so I need 2 of them. So I have 23. I got this one right here, but I need a cable for this one right there. So 23 times 2 is equal to 46. About 46 meters of cable is going to be needed for this communications tower. And that's everything. Hopefully it's clear. Make sure to do the examples. Make sure to do practice with this one right here. If you have any questions, please do let me know. I hope you have a fantastic day, and I will talk to you later.